For years, the void between stars has kept its secrets. A place beyond reach, beyond light, beyond comprehension. But now, that silence has been broken once again. Not by chance, not by accident, but by something deliberate, something approaching. A comet. But not just any comet. This one is different. It's coming fast. Faster than any interstellar object we've ever seen. It's massive, bright, red, and ancient. And what's worse, it's headed directly toward the heart of our solar system. The James Webb Space Telescope, along with a network of ground-based observers, has sounded the alarm. This isn't just another cosmic rock. It's the third object in history to pierce the veil of interstellar space and enter our domain. And the data it carries, its shape, its composition, its impossible trajectory might be telling us something we're not ready to hear. Because what this object reveals about the universe may also be a warning. When Oumuamua streaked into our skies in 2017, it captured imaginations across the globe. Then came Borisov in 2019. Icy, fast, active. 2 interstellar visitors, unexpected and unexplained. But then the cosmos fell silent again. For 6 long years, nothing breached the solar bubble. Until now. On a quiet July night, the Atlas Survey Telescope in Chile detected something unusual, an object moving fast through the direction of the Sagittarius constellation. At first, it was just a faint blur, insignificant, maybe a leftover asteroid. But as more images came in, astronomers realized the truth. This was no local object. It was hyperbolic, on a one-way trajectory from beyond the solar system. The name, 3I. The third known interstellar object. The third trespasser. And almost immediately, the warnings began. With an eccentricity of 6 and a velocity of 58 km per second, 3I Atlas is unlike anything we've seen before. It's not just passing through. It's cutting through our solar system with extreme speed and energy. A cosmic blade moving faster than both its predecessors. Its hyperbolic arc isn't just a visit. It's a slash across the fabric of solar equilibrium. And yet, we know almost nothing about what brought it here or what it carries with it. The James Webb Telescope, though not designed specifically for comet tracking, has joined other observatories in studying this anomaly. And what the data shows is unsettling. 3I Atlas is massive, 10 kilometers wide, making it larger than Borisov and Oumuamua combined. It reflects a strange spectrum of light, redder than expected, rich in carbon. But what truly puzzled scientists was its brightness. From late May to discovery, its magnitude jumped rapidly, and its tail, faint but measurable, spans over 25,000 kilometers. That's no dormant rock. It's active, awake, and it's old. Based on velocity models, 3I Atlas may be between 3 and 11 billion years old. That's older than our solar system, older than Earth. It could have been wandering the interstellar deep before the first star in Orion was born, which raises a question that no one can yet answer. Why now? What force sent it hurtling across the galaxy at such a speed and on such a precise trajectory that it would arrive here? Now, this is not the first time we've seen an interstellar visitor, but 3 objects in 6 years after a complete absence for millennia is no longer a coincidence. Scientists are now asking whether this is the beginning of a new cycle or the continuation of an ancient pattern. Each object has been drastically different. Oumuamua was dense and rocky with no tail. Borisov was volatile rich, spraying carbon monoxide like a geyser. 3I Atlas is somewhere in between, active but oddly restrained. All 3 come from different angles. All 3 show unusual light curves. And all 3 challenge what we thought we knew about cometary formation. But here's the twist. Interstellar objects aren't just teaching us about where they came from. They're revealing something about our own place in the galaxy. Their trajectories, their compositions, their behavior as they interact with the sun, they all suggest that the space around us is more connected, more alive than we ever imagined. And the more we watch them, the more it feels like we are the ones being observed. So where did 3I Atlas come from? The clues lie in its structure and motion. Its hyperbolic path suggests an ancient expulsion from a distant system, possibly a red dwarf rich in carbon monoxide. The comet's deep red surface and volatile emissions hint at extreme cold conditions that exist only in the outermost, slowest forming parts of a solar system. But here's where it gets truly bizarre. Some researchers suggest that objects like 3I Atlas might not be entirely natural. That perhaps they are fragments, remnants of something bigger, maybe even manufactured. A few even go as far as to speculate, could these be artifacts? Discarded relics of ancient civilizations long extinguished by time? Signals we cannot decode. Structures we cannot recognize. There's no proof, only patterns. But James Webb is watching. And as this object swings past Mars, past the Sun, and back into the unknown, we have only a narrow window to learn all we can. Because who knows how long it will be before another one appears or what it might bring with it. As 3I Atlas was tracked more closely, astronomers aimed to understand its spin. Using precision instruments from Lascumber's observatory, they analyzed its brightness over time, searching for rotational variability. What they found added yet another layer of intrigue. The comet rotates once every 29 hours, a fairly slow pace for an object of its size and speed. But the real shock came from the light curve. It was flat, only 0.2 magnitudes of variation across its entire rotation. That means the object reflects light almost evenly, without dramatic peaks or dips, suggesting an unusually symmetrical surface or a balanced structure. That's uncommon for comets, which are typically chaotic, cratered, and lopsided. Some have speculated that this symmetry could hint at a deeply frozen, undisturbed surface, perhaps one that hasn't been exposed to star systems for millions of years. Others suggest it may not be as naturally formed as we assume. But what's most compelling is how much 3I Atlas doesn't resemble its predecessors. It spins slower than Borisov. It's smoother than Oumuamua. And it's traveling significantly faster than either. These factors don't just make it strange. They make it singular, unique, an object that breaks the mold and therefore demands our full attention. As telescopes scanned its surface, researchers began searching for indirect signals, changes in magnetic fields, shifts in solar radiation, and variations in charged particle densities. And in one observation, buried in layers of electromagnetic noise, they found something, a faint but persistent pulse. It wasn't a signal in the traditional sense, no modulation, no frequency hopping, but a subtle fluctuation in the local magnetic environment. Every time 3I Atlas changed angular position relative to the Sun, the background field warped ever so slightly, as if the object was subtly disturbing space around it. That could be due to its high speed, its volatile emissions, or perhaps something else entirely. This prompted a wave of theoretical models. Could it be shedding particles invisible to our senses? Could it be surrounded by a field of ionized gas or even dark matter? Or more dramatically, could it be reacting to the solar wind in a way we've never seen before? Because the James Webb Telescope wasn't just observing 3I Atlas. It was watching how the space around it changed. And in those interactions, there was one conclusion few were ready to voice. Something about 3I Atlas didn't just come from interstellar space. It remembered it. After months of tracking, researchers began using the discovery of 3I Atlas to update a fundamental question in astrophysics. How many interstellar objects are out there? The number was expected to be small, but 3I Atlas has forced a revision downward. With only one such object found in years of continuous observation, scientists now estimate the density of interstellar objects to be about 0.001 per cubic astronomical unit. That's staggeringly rare. It means the vast majority of space is empty of wanderers like this, which makes their recent appearances feel intentional. 3 in 6 years, all radically different, all appearing in windows where our observation capabilities had just matured enough to see them. Is this simply cosmic coincidence? Or are we part of a much larger system we haven't yet recognized? A galactic rhythm that operates in timescales far beyond ours. Maybe these aren't just travelers. Maybe they're messengers, or worse, monitors. Because if the data is correct, 3I Atlas shouldn't even be here. And yet, it is perfectly timed, precisely angled, and moving faster than anything we've ever seen. Comparisons with Oumuamua and Borisov are inevitable. But what makes 3I Atlas feel more ominous is not just its scale or speed. It's the context. In 2017, When Oumuamua arrived, we barely understood what we were seeing. In 2019, Borisov offered data